Now, you probably guessed from this title that the objective for me was building some new software and some maybe new interfaces for vintage computers and FPGA projects. The one I wanted to really do to use my CompuPro 816, which is a multi-user system set up for 7 users, 7 serial terminals, and 1 PC video terminal, is to make use of that at the show in an entertaining way and to show the power of the multi-user operating system from the early 80s that many people don't even know exists. So as part of that effort, we bandied around things over the past year or two as to what we could do as a S100 Computers group, or more specifically, what I could do on the machine to show in this kind of setting. One of the concepts was the multi-stations from the war games. You know, do you want to play a game? That kind of dialogue going on. Another session that came up was multi-user Pacman. So in this concept, you have the PC video terminal, the central terminal, we're running Pacman and the maze. And each of the serial terminals actually it represents a ghost that can chase down Pacman and the maze. So just to get an overview of the final product, this is it running earlier in the show here. And there were people driving the Ghost going after Pacman. And one of the ghosts got him. So. And you can see they're all moving against them because they're all coordinating to go chase down Pacman. That was one of the fun aspects of the game. It really made it much more challenging. All right, and this is where I got it sideways. Sorry. All right. So that was the final product. What started this whole thing is just the thought of, what can I do about this? What I wanted to do was create a program with vintage tools. In other words, I'm not going to use a compiler from a modern era to generate this game for a 1980s vintage concurrent DOS system. What I wanted to do was use a compiler that was common to that era. For that, I chose Turbo Pascal 3.0. Also, it's running the original OS. There's not an updated OS. This is the OS that existed in the early mid 80s as a multi-user, multitasking operating system. So everything shown in that video that you just saw could have been done in the early to mid 80s. Just lacked the concept to do it, right? But all the technology was there, all the serial terminals were there. So that's really what I wanted to show for that era. Now, let me introduce myself, given that slight pre-intro. Hello, VCF Midwest. Hello, I'm Jeff Wilson. I'm an engineer, electrical engineer with 40 years experience in gate array design, graphics chipset design, SoC design, GPS RF design, layout. And I've done a number of boards at the show. If you want to see what I've done, I'm over at B04, P05 table set if you want to see some of the stuff we have. With that out of the way, let's get into this. So, are we ready to play PAKU? Well, here's the challenge. So what do you do at VCF Midwest was a 7-user CompuPro 816 system from the early 1980s. Why? Okay, we're going to create a 5-user Pacman game. 1 Pacman player, 4 Ghost players. And I was also playing a game of Zork on one of the other terminals, so all at the same time. But I only had 3 months. This concept wasn't even started till June timeframe, and finally got off the ground in July timeframe. So you're seeing the product of programming over 3 months. Now, you could say, okay, it wasn't that big a project to program in 3 months. Well, what's the big deal? Why use AI? Well, I have a job that challenges me to 70 hours of work a week. I have nightly calls to customers in Japan that I have to support. Finding spare time in my life to actually do this is one of the biggest challenges I had. And I wanted to look at ways to how can we accelerate this? How can we get this out the door faster? So I said, well, I use AI in my day job. I use it for data analysis. I use it as a superpowered search engine. This seems like it might be a good idea to try. All right. So perhaps it can help, but every AI doesn't work without a context. They need structured questions, structured interactions. You need to know things before you even start talking to the AI. Like you got to define what the project is. You got to know that's a guiding statement. You got to define the why of the project, or the goals, development environments, the tools, the operating environment, the architecture. All of those have to be pretty much, if not nailed down, they have to be laid out in a way that you've got a somewhat clear picture of how the broad pieces are going to fit together. So I'm going to present you what I did, and you can learn from it because there were mistakes, and there were plenty, intentionally so actually, to show the first time AI user where the pitfalls are. Okay. First, let's start with what we had. Jason M. Knight wrote a game called PAKU in the early 2010s that was based on Turbo Pascal 7.0 for PC DOS, MS-DOS, and he did several revisions of it. He actually did a great job on it. He used a 160 by 100 character mode to have 16 color graphics on a CGA display that normally would only give you 4 at best, and 4 crappy ones at best. He developed that concept. Okay. So that was a starting point. Okay. The structure's been done. That's sort of the goal. That gives me a goalpost to aim for. Now, why? Why am I doing this? Because I can, because I wanted to, because it was going to be fun. And like I said, I'm probably a little bit techno-masochistic. It defines a lot of the work I do. And put simply, it's showing the power of this CompuPro 816 I have. Running these ghost terminals and still running Zork on the side. This is a system that was built in 1983, running a leather business nationwide. People forget these mid-MGs even exist because everything went PCs later in the decade. So this is like a snapshot in time for what a business would be doing in that era. All right, what are the goals? Well, I want to reimagine PAKU on 80s hardware. I want to use 80s vintage software tools, and specifically Turbo Pascal 3.0, Concurrent DOS 4.1. All of these were early mid-80 software releases. And also to have fun by giving the ghosts a chance against Pacman. Right now you've got players that are more invested in going against Pacman back and forth, and it created some fun game interactions. I'll talk about that in a minute. And just overall to have fun. All right, let's talk about the environment, because I don't expect a lot of people know what CompuPro 816 is. I can make hand gestures and shadow puppets, but probably better to just look at it. So what it is, it's a multi-user S100 system. It was developed by CompuPro starting in the 70s. Moving into the era of the 80s, it became a full multi-user setup for large business offices. This system, when new, would sell between $40,000 to $65,000 before you even bought the terminals. This is in 1980s dollars. But if you compare the cost of a PC at the time, like a PC XT, $6,000. You bought the monitor for another $1,000. You bought all these components, so you're into a PC architecture for $7,000, $8,000. And if you need an office of 7 users, multiply that up, and you can see where this starts becoming a benefit. You buy it for $40,000, and you now have an expandable capability. Plus, it's scalable. You keep adding more things, and you all are sharing the same files on the same system, so you don't have to necessarily set up networking. It just makes it more self-contained. Anyway, so this system was one of the power users of S100 in the A's. Were there more powerful systems? Probably, but they're usually scientific and very even higher end than this. What this system has is a 286 CPU, 3 Z80 slave cards for running CPM80 applications, a PC video board, which is CGA compatible, floppy disk controllers, serial ports, network interfaces. The only new card in this system, is my RetroTalker board, which is a reproduction of the Netronics electric mouth Digitalker board from the 1970s. 1977 specifically is when that card came out. So I don't consider that anything that couldn't have been done in the 80s. The cards are already there, right? Maybe change some of the circuits on the card to make it a little bit better in a high-speed bus architecture. But other than that, all of the equipment was there. All right, the OS. How many people have heard of Concurrent DOS? 2. Okay. So let me describe. This is a digital research product that sprang out of first CPM, then going to NPM, multi-user system. Out of that became concurrent CPM, concurrent CPM 86. And then following on from that was concurrent DOS. And then following on from that was concurrent DOS A16. This operating system had the capability of running CPM80 applications, CPM86 applications, PC-DOS applications, and MS-DOS applications, all in a multi-user environment. And this was in the 83 to 85 timeframe. So there was no PC running at that time that could do this. This is a very unique business architecture. So why did I use it? I love the CompuPro, and I wanted to show something with this program that exemplified the multi-user nature of it and some of the advanced features of the OS. All right, let's talk about the compiler real quick. Has anybody programmed in Turbo Pascal?
Turbo C.
Yeah, so this is much earlier than that. Turbo Pascal 3.0 was one. Well, I actually had a copy of Turbo Pascal 1.1 back in the day for CPM80, and then later bought it the 3.0 copy for CPM86 and MS-DOS. It was very fast compiler, but it had limitations. It was a one-pass compiler, so forward references weren't allowed. There were other constructs that were different that modern compilers take care of very easily. Like you could do a constant declaration at the front of the program, but because it was a forward pass compiler, you couldn't use those constant declarations for declaring other records. You actually had to hard code say the array type. You couldn't create a constant set. My array size is 20, and then use that constant and array declaration, because those weren't actually used till the program statement. So lots of features like that really could hang you up. And I'm going to get onto it here. And as I was talking about earlier, this is the only new board that I added in the system, and it's a copy of the board above. That's a true electric mouth from Netronics from 1977. You can see a little bit of the ad there as well. That's basically a compressed speech synthesizer. All right, dual chain. So I've said a little bit of this already, so I'm getting ahead of myself, but it is a single pass compiler. The implementation of the documentation is important for what happens when I did this work with AI. Because this manual, it's a 500-page reference manual of Turbo Pascal 3.0. What they did when they wrote this reference manual, they didn't make it specific to CPM86. They actually, because they had the product in 3 different ways. They had it PC-DOS, MS-DOS, and CPM86. And just for fun, they also had it cover CPM80 applications. So we had 4 different implementation contexts in the reference manual, and they weren't always called out as to what applied to what. So this became a problem when we were using it for writing code. An example of this is CPM80 BIOS calls, completely different from the CPM86 ones, which were also completely different from the MS-DOS ones. So the AI in this case kept mixing them up. Kept having to correct it. And all those implementations were in the manual. So yeah, I kept telling it, okay, don't use that one. And it would say, oh, you were right. And then a couple of tries later, it would come back and do it again. And I'm sure everybody that's used AI has experienced that sort of recurring error context. They call it an hallucination. You know what it really is? It's waiting, right? You're telling something's wrong and you're a human typing it in, but the documentation says this. Now, it tends to believe the hard stuff that we upload, the program text, the reference text, so on, as having more weight than what we type in on an individual statement. So they'll correct it for that cycle because you just typed it in. And then as that cycle gets older, it gets less weight. That's exactly what's going on in that cycle. You're losing the weight of what you told it to fix. And then by the third iteration, it decides, oh, okay, I see a problem here. This had more weight. I'm going to, and I'll fix it. So that's I'll get into the reasons why further, because I think a little earlier to talk about it just now. Okay, so here's the operating system environment. As I said earlier, it's a continuation of CPM going up to concurrent CPM 86. For your interest, this also became concurrent DOS XM for PCs, concurrent DOS 386 for PCs, and DR DOS. And later, when Digital Research was bought by Novell, it became Novell DOS. And that exists now today in the ecosystem on the web as FreeDOS. So it's still out there. You can still download it. You can still use it. This OS is still getting developed in certain areas. Haven't you used FreeDOS? Yeah, so some of the features there are pretty nice. It's just interesting that this evolution has continued to today, at least to me. All right. So what did this particular version of concurrent DOS 86 have that we used in PAKU? Well, when I'm dealing with multiple programs running, to handle process interchange, you don't assign a priority to the message in this concurrent DOS thing. You have to, the way it handles message arbitration when you're sending messages between processes running on other terminals, is it does it by a priority setting of the process itself. So, for example, the priority setting is a call to the BDOS where I say P priority. I tell it the priority of the master program, and in each program running on the serial terminals, they have a higher priority. That may sound like it's inverted because the master program sounds like it should be the big, the one that's always in control. But I'll explain on the next slide why that doesn't work. Anyway, the message queues are also unique to this OS in this time frame. MS-DOS, PC-DOS didn't have any of this. This was a way of doing inter-process communication across the entire system. Raw console I/O functions, that was fairly standard. Here's the other thing that it had. It had a delay function, but this is not the delay function that we often think about where you have a while loop just sitting there doing a delay. This, in fact, the name delay is probably a misnomer. What it really is a deschedule event. So when you call this delay function, you're telling the operating system, I don't need to run for this period of time. Go run something else. And the operating system will then go and do that. Okay, why is that important? If you never give another process time to run, it won't run. If you're a higher priority and you want to run all the time, you will run all the time and you'll lock everybody out. So these scheduling events are important to manage inter-process communication and program flow across various terminals. All right. Here's what it looks like graphically. This is the PAKU program and the Ghost program and how they talk together. And I think I'm going to get up to actually point on this one because otherwise I'm just moving a cursor around and it doesn't feel very natural. So I'm going to play the Mari Povich and hold the mic around and point out. The game, in the PAKU side of things, the game loop starts or restarts. Depends on how many times it has to go. And the first thing it does is it starts, okay, where do I have to move ghosts? There's a little AI pattern that runs, and I move the ghosts. And then I collect any user input. Has the user pressed a key to move left, right, up, or down? Then if he has, I move PAKU. I then check to see, has PAKU collided with a ghost? Did they overlap? And if the power pellet hasn't been eaten, PAKU dies. If the power pellet has been eaten and the timer hasn't run out, the ghost dies. So that follows with certain things as you go on from there. Once I've figured out all the overlaps, collisions, and everything else going on, I will draw the entities as they currently exist on the CGA display, the main console. And then I use all of that and I update the queue data. Now the queue data structure is what I send to all the ghosts. And here, you have to do something funny. There's two methods of doing queue calls. There's a blocking and non-blocking. If I used a blocking call here and none of the ghosts were running yet, nothing would happen. Everything would freeze here. You couldn't put in keys. You couldn't do anything with it. It would block. So they have something that's called a conditional queue call. And here, what I'm doing is I'm doing a conditional write. And the size of the queue is one transaction. So I'll do a conditional write. The first one basically accepts it. And what happens there if the ghost is running? He receives it. Well, I'm going to come back to the ghost in a minute. We're assuming that everything's working okay over here. And when I come back to it, I'll go on to how these interact. On the queue read, I do a conditional read. Is there anything waiting there for me? Do I have anything to pull in? If I do, I then decode what the ghost is telling me in terms of his positions. I process where that is in the queue, right? And if I get a queue full, I'll sometimes come back here. But then, excuse me, then I also process any key commands that were put in up here. And if I have a quick command, I will exit. If I don't, I'll come back and do the move ghost routine again. Now, on the ghost side, what I'm doing is this is blocking. It means I am going to wait here as soon as I hit it. So the ghost starts up, draws its maze so you have something on the screen. It then waits for a queue read. If there's no queue read, it'll wait there forever. It won't do anything. As soon as it receives the first queue read from the PAKU program, it decodes it, it checks for any user input, it updates its own queue data, and sends that information back to the PAKU program. And then it'll draw its entities, it'll check what the state is. Have I been told to restart, in which case I got to redraw the maze? Or have I been told to quit, in which case I better quit? All right, so the flow of this basically is, if you look here, the priority here is 200. That's lower than the PAKU priority. And the reason for that is every time PAKU deschedules to do this a successful queue write, because this is higher priority, it'll immediately schedule. And it'll run. And it'll run to completion. It'll draw everything on the serial terminals. Once all the serial terminals are done, it'll respond back. And because it's a higher priority here, it'll run through this, come back to the main loop, or come back to the main loop here, and get stuck at this queue read again. And as soon as it does that, it's waiting for a message from the main program. Now that it's descheduled, the lower priority process on the main program can run, and you go through its loop. So this is how the timing works between the two. You're basically handling the flow of information by process priority and queue management. All right. So that was the architecture I started with. Great. What does it have to do with AI? Well, let's go on. Let's talk about AI. So when I started this process, there are still questions, and you hear these questions in AI a lot. Is it legal to upload any publicly available document into your AI engine? Any thoughts on that? Yes and no. I'm talking about your private account. So you're not training necessarily. You're giving access to information, right? You would think so. Yeah. Okay. I'll talk about it. It is a little up in the air. Current case law is mostly on the side of if you own it, you can do it. You can upload it. I own a copy of the Turbo Pascal 3.0 reference manual in hard copy. I own a copy of the Concurrent DOS programming manual in hard copy. So, okay, current case precedent, the majority of it says that if you own it, it's basically like putting your own copy into a hard copy on your disk drive. That's how they view the uploading process. But if you don't own it, then and it's copyright protected, then you're stealing it by uploading it, right? Now, there are public domain documents. I'm not talking about those. Those that are clearly public domain, not covered by copyright, you don't have an issue with. But it's not really settled what you do with, say, I downloaded the Turbo Pascal 3.0 reference manual from archive.org. If I didn't own a physical copy, would it have been legal for me to upload that to the AI?
Yes.
Yeah. Well, we say that, but archival purposes don't necessarily mean distribution purposes. And this is where it's gray right now. This is where Now, the individual hobbyists here, I don't think they're going to come after you. I really don't, because it's you're doing one thing. You're not making a derivative work. You're not substantially changing the original work. You're not doing any of that. So it's more on the side of, can you own that copy to be able to do something with it? And most of the stuff on archive.org seems to pass that test with certain copyright laws. And the copyright laws are basically focused on redistribution and recopying. Okay, fine. So it's kind of coming onto the side of fair use. In other words, can I take portions of this and use it? Yeah. All right. By uploading it to an AI, am I taking portions of it and use it? Current case law for the majority says you can. But there are some ones that are saying you can't. This one by Ross Intelligence said if it's copyrighted notes and they object, it's stealing. So, and some publishers have not stated their opinion on it. Archive.org actually has this problem. Some of the stuff up there, the publishers of that material have not stated their interest in it. And you'll see some notes in there about that when you download it. You'll see, is it still under copyright? Do you still have rights to distribute this? And it will say currently copyrighted material. So I'm not saying you're going to get in trouble. I'm not saying someone's going to come after you. I'm just saying if you're doing this for large projects and getting wide distribution with it, it might be something you have to consider. Okay. And like I said here, conclusion is that they seem to be leaning in the fair use argument for these materials. How do you protect yourself if you're really nervous about it? Do what I did, buy a copy. All right, you can buy Turbo Pascal copies on eBay. I've bought this digital research copy for Concurrent DOS 816. Not that I think Novell's going to come after me, but you kind of see where I'm coming from here, right? Okay, more elephants. Can I say I own it, can I upload it? Sure, I can. I'm further buttressed in the point that Turbo Pascal released version 3.0 to the wild. They gave it to people to use as a freeware. The only unfortunate thing in the way they did it, no reference manual uploaded. There's only the compilers and its associated data files with it. So that's still in a gray area a little bit, but I'm leaning more on the fair use. I own a copy of it, and this would apply more if you didn't have a copy of the manual. Okay, so if you want complete coverage, buy the manual. Turbo Pascal, the reference manual is still copyrighted. A little bit of gray area if I can distribute it to an AI, but if I own it, I can, is the precedent. Okay. Some more stuff. I use AI in my day job, and because I have a AI account and a AI engine that's in my day job, I didn't want to mix that with an AI, the same AI, and this private stuff I'm working on. They say there aren't leaks, but there can be leaks. And if the AI somehow associates my work activity with my private hobby activity, this could start creating some bleed over, some cross problems. So I specifically chose, in this case, I chose Grok because it wasn't my work. I've got a couple different work AIs I use, and it wasn't either of those. So Grok was the easier choice for me here. Your mileage may vary. Pick the one you want. If you don't have any bleeding problems with an employer like I do, then don't worry about it, right? Don't just use what you want. The other aspect you may run into is unintentional violation of copyrights, right? Are you going to get sued? Probably not. For vintage material, I don't think anybody that wants to go try to gain money from a hobbyist from a product that was engineered 35 years ago is going to come after you. Yeah, exactly. That is my point there. The only problem is there seems to be a class of copyright lawyers that are now going out and going after people that are uploading or going after certain materials, not for the gain of the company, but for the gain of their own prosecution, because they can force a legal judgment against you. And it's not the company doing it, but they act in, quote, the fair interest of the company. So That's one to watch for. I've seen it professionally by companies that do this. They'll go after people they can verify have, and it's usually not one copy they're going after, but if say you like did this 10 times with 10 different products and it became really high profile, you might become a target of that kind of legal harassment. So something to be aware of. And that's why I said it's, you know what, if I need to buy the copy, I'll buy the copy. That'll kind of alleviate that risk if I have to alleviate it. All right. This one's a big one. Loss of situational awareness. Right? You're asking the AI to do certain sections of your code or all your code. Do you really know how it works? Do you really know how the AI structured it? And it may appear to run, but there may be some things hidden in there you haven't seen or uncovered yet. So having the AI do it all, or even large portions of it, could end up with a situation where you don't have enough situational awareness about your program to even debug it. In that case, there are fallbacks we can do. We can do things like ask it to come up with a debug session for the program. Ask it to put in debug statements, things like this. All right. This is the very biggest one in my talk today. Garbage in, garbage out. I'm not going to go too deep on this slide, but the answer to garbage in, garbage out is verify the textual data that you're uploading. I'm not talking about images. I'm not talking even about PDF scans. I'm talking about the text data in those scans. All right. And this is one I know is a pain point for people, is the loss of tech jobs due to AI. In my company, we don't use it to replace people. We use it to speed up processes, right? The focus is on, I've got to do this task. I know how to do this task. I just don't want to spend 2 hours typing in all the statements to do this task. So I define it to the AI in a very clear term and ask it to do it. Then I review it, right? So it speeds up the process. It doesn't replace the architecture. It doesn't replace the actual code knowledge or how to write in that language or any of the other functions, but it makes it faster. Are we losing tech jobs over that? I don't know. Maybe we're producing stuff faster. Maybe we're getting to revenue faster. Anybody, I'll ask a question and answer session at the end. I'd like to hear your opinions about what you think about that at the end of the presentation. So keep it in mind. I'll come back to it. All right. Oh, and one other thing to note, some publishers on material are starting to put license inclusions that it cannot be uploaded to an AI. So if you're using any modern distribution of something and you think, oh, well, go to a GitHub. Oh, this is, GPL. We're LGPL license release. I can use this, right? Well, look at what they have in there. They may have an exclusion for uploading to AI. And if they do, you shouldn't be doing it. That'll be calls for legal action if they find it. So just to be aware, some people are getting very antsy about that. Check the materials that you're uploading. All right. I've talked about the negatives. What are the positives? Well, we can put code on the bones of a software architecture. Notice I said on the bones of, because I feel you need to have the architecture first. If you just say, write a program that gives me a PAKU, you're going to get some things. And I did exactly that for an example point, but I'm going to come back to it. All right. Also, you can use it to act as a supercharged search engine. I was researching how to do the 160 by 100 special configuration mode for CGA. And I was trying to find code examples written in assembly. So I asked it, okay, can you find me these code examples written in assembly on the web? And please make sure it's open source code. And Grok came back with a bunch of suggestions I was able to dig into. So it just sped up my time rather than me sifting through all the responses that, say, Google.com's going to give me versus it goes and summarizes it for me. It can help you review your code for mistakes. And I think that's a big thing. Like I'm dealing with two programs, the PAKU program, the Ghost program. I asked the AI, can you compare the Q structures between the two and make sure there's no data misalignment? And it comes back and does a compare and it says, no, they're aligned. You're good. Very quick function, right? Saved me probably a good 10 minutes of reviewing all the data structures. suggest new solutions to coding problems. Also have it trace down, ask for opinions on root causes of an identified bug or some behavior you've seen. Like I had a problem with my ghost behavior and I didn't exactly narrow it down to the section of code because there were lots of areas that touched that behavior in the program. So I asked Grok, can you identify why this AI ghost movement program is behaving like this? And I came back and said, oh, there's this clause in here in this if statement that's blocking it moving in this particular direction. And so I was able to fix it pretty quickly, identify it and find it and fix it. And you can have it rapidly speed up tedious sections of code. So, for example, I have various bitmaps in the PAKU program. That's a lot of stuff to type in hex code for doing individual bitmaps for everything on the screens. So I asked it, can you create the structures to these bitmaps based on this bitmap image? And it created all that for me. That probably would have taken me, I don't know, 15 or 20 minutes, but it was a nice relief. It could go faster. All right, what are the pain points? I've talked about this before. The garbage in, garbage out is a huge factor. It's probably the biggest factor for vintage materials. Hard copy mistakes, bit rot, and OCR errors are the primary cause of this. So due to token weighting, also these hard copy mistakes can persist. We talked about it earlier when we were just starting the conversation, that because of the weighting of the AI, you've uploaded this hard document copy. What you say as you type in doesn't have as much weight over time as the hard copy does. So problems will come back. In other words, it'll assume the hard copy is right, even though it's not, and you've told it to correct it, and it'll start persisting these errors over and over again. If it happens again and again and again, sometimes the only thing you can do is to fix the hard copy and restart a new session, because the weights are always there. And I've even tried uploading correct data, and now it has one correct, one incorrect, and it still comes back. And the easiest way, and I've deleted it and started a new session and gotten further along that way. Incorrect terminology. Okay, maybe you're a new coder to some process you're doing, and what you're trying to describe is not technically correct. You're not using the right technical words for it. Like, for example, structures in Pascal are not called structures, they're called records. But if you're a C programmer coming into Pascal programming and you're saying stuff like create a structure to do this, now what you're doing is you're confusing the AI by telling it to do one thing that it can't find a listing for in the Turbo Pascal syntax. Doesn't know what you're trying to do. It knows that you're trying to create a structure. If it's smarter, if it's had it before, it may know that it has to create a record from that, or it may not. So if you know the language a bit, try to use the language elements correctly. Don't use mix C terms in, don't mix in, Python terms in for certain functions or things to do. Try to keep it in the context of what you're working in. Okay. How many people here have heard of Dave's Garage? Most people? He did this great YouTube video where he decided to just buy time on every AI that he thought, well, at least these 4 AIs, ChatGPT, Claude, Gemini, and Grok, right? He has a very good video on it. I link it here. After this, we can share a presentation so you can link to it as well, where he breaks it down one by one. So, hello. His conclusion on this is that Claude and Gemini were very good programming AIs because that was their intended purpose. Grok is more conversational, more context aware, and as is ChatGPT. Your utility at it, if you're writing large programs, also depends on what the context window is and how many tokens the AI can handle, right? So ChatGPT, I always have problems. I want to say GPT, can handle 128K tokens per section, which translates to about 96,000 words of text, right? That doesn't mean I can upload that and it can work with it. What it does is it tokenizes everything you upload. So if you upload too much, it starts having problems comparing all of these. Claude is a little bit more better, about 200K tokens or 150K words. Gemini, this is the one That's the big code development engine of late. That one is 1 million tokens, or about 50,000 word or 750,000 words of text. And lastly, Grok is about 1 million tokens with 750,000 words of text. They're working on the Super Grok 4 right now, which I hear is even more. They're talking about 4 million tokens as a possibility. It's not out yet. So these context windows are getting large. They're getting huge. But that can also create a problem too, in that if it's so large, then it may take a while for it to work with it. I've asked Grok a couple of times on certain things, and it's taken like 10 minutes for it to come back to me at times. Some of that's loading of the servers, but some of it's also just the amount of context you had, because I'd uploaded a 500-page document, another 300-page document, and like 2 or 3 different source code examples. So that was a lot of tokens, and it took a bit of time to come back. But I recommend going to see Dave's Garage video. He gives you a lot of information about it. Now, okay, this last topic on this page is, if you don't want any data leaks at all, if you really are scared of having any of your information get out into the wild through AI, you can create your own AI on your own network. Network Chuck talks about this. He uses Llama on one of his network machines running with a couple of GPUs. Personally, I'd only consider this for something like a home assistant set up in a house, so it can recognize human voice, human text, that kind of thing for controlling house functions. But some people are using it for search functions, doing searches across the web and so on. But now your machine's going out on the web with it. But if you want to host it yourself and keep all that context information to yourself, you can host it at home. You have to have some pretty heavy hardware the higher you go here. You're not going to match 1 million tokens on a home machine. But you can get close if you want to buy a server farm of GPUs. Leave that up to you. So here's a couple of videos where you can look at how people did that, how these various network guys have hosted their own AIs. All right. So this last approach, this is something that's distributed among a lot of the tech companies on how do you talk to an AI. A lot of times we just like want to throw one question at it, right? Usually that can produce a singular response, but if you're wanting to do a process of developing a program or a context or a document or whatever you're trying to develop, there's these interaction dialogue templates. I gave a link there at the bottom for where this is done. This is a guy on LinkedIn who's worked with AI companies to define these interactions for giving you the best bang for the buck for the interaction. So I'm not going to read through all of them right now because I'm going to be running short on time if I do. But the one I ended up doing was the context action result example, but in a modified way. And I'll go on to that now. So here's what I did. This was the very first time out with the AI. I actually they said something along these lines, a little paraphrase, but I said, given the Turbo Pascal reference manual, the CompuPro PC video manual for how to drive a CGA display, and referencing the online PAKU source code, please build a Turbo Pascal 3.0 version of PAKU for concurrent DOS. And I specify in CPM86 format. So Grok produced a program for me, believe it or not, just based on that information. But it assumed that the CGA display was monochrome text, so it substituted characters like I think the G character was used for Pacman and things like this. And I guess it had found some text-based Pacman games on the web to reference for that. I'm not really sure where that particular thing came from. It also used a later Turbo Pascal syntax 7.0, which I kept creating compilers, which I knew it would, for forward references and other things. And I think that's because the original PAKU program was written in Turbo Pascal for 7.0. So it was borrowing a lot of that. It also assumed a multipass compiler. So after more iterations of fixing all of that and requesting a 160 by 100 color mode, inline assembly mode, and screen updates, I still had problems. I was getting incorrect inline opcodes and hex values repeatedly. This was due to OC errors, so I'll go on to that in a second. I was getting incorrect indexing on the on-screen pixel addresses because it kept confusing character indexing to the CGA array versus true graphics mode, which the 160 by 100 is a character mode where the character is only 2 pixel rows high. So you got to treat it a little special. And it was kept going back to, oh, you're talking to an 80 by 25 column display, so I'm going to do all that kind of addressing. So, and that took time to fix. One point when I emphasized that the text mode was not text mode, but was being used as a graphics mode, it decided I wanted to have the 320 by 200 CGA graphics mode, and it did that. So being correct and being clear for graphics modes, unfortunately, this 160 by 100 is not a standardized mode in any of the IBM documentation. It was sort of this bodge done by gamers, and Grok didn't know how to treat that, right? It didn't know if that was a real thing. And incorrect built-in procedural call formats. And this is more because the Turbo Pascal manual covered 4 different implementations of Turbo Pascal. So it kept picking the wrong one. All right. Why was that all a problem? I uploaded the reference manual. It was all there. Well, it was because Grok did not see the same thing I saw. Here's what I saw on the left, directly out of the Turbo Pascal reference manual for an inline assembly code. What the AI saw, everything in yellow is a OCR error, right? So it kept coming up with wrong opcodes for instructions. It kept coming up with wrong commenting because the comment characters disappeared completely. Do I have to get louder? I think because of this. Here's another example. This is from the Concurrent DOS 816 Programmer's Manual. Here's what I saw for a Q perimeter block structure that I was using to send messages, information in between processes. This is what Grok saw. Do you think it could build a reliable record structure out of that? So the problem is not that we don't have the documentation. The problem is we don't have the documentation that's compatible for a machine readable format. The scan codes have the scan documents have primitive, even if it's available, OCR text, and Grok doesn't see the image. Grok doesn't do OCR text or recognition. He does text recognition, and so if the text that it sees underneath the image is wrong, it comes to wrong assumptions. I actually got Grok hallucinating over this several times. All right. Now, so what do we do? I reached a point when I discovered, well, I shouldn't say I discovered it. I was kind of half expecting this outcome, but I just didn't know how bad the Turbo Pascal reference manual was when I started, because it looked good to me on the, right? I'd have to copy and paste everything out into a text editor to see the errors, and I didn't do that. I just threw it at it. So what do? We could be trying to swap documents around. Go across the internet, look for one that's better, but you're going to be cutting and pasting stuff out of every document to see where the errors are and if it's going to be critical. Is it easy to do that? No. I mean, the Turbo Pascal reference manual is 500 pages. You want to copy and paste 500 pages of text off of different uploads to see which one's most correct?
The scanner to scan the manual.
Yeah, but who does the OCR?
Sorry,
Who does the OCR when you scan it?
who does the OCR?
Yeah. Are you going to use a PDF editor to generate the actual text underlying it? Are you going to go to AbiFine Reader and ask it to do it? Or are you going to go to a free web page that says, I will OCR your text for you? Yeah. All of them have problems. And I'm not blaming the technology. What I'm saying is, if you think about the fact that typefaces change from a lot of these manuals are written on selected typewriters. Right, they were typeset at book publishers with that book publisher's chosen set of font characters. They're not all in Times New Roman. It's so the OCR has the problem. It's got to interpret these character sets of all different font manufacturers, font types, and have to deal with bad imaging from copying. That's a problem too. What if the only copy you has is a very faded dot matrix printout of a program? You start seeing where all this stuff accumulates. So do you really want to spend your time trying to correct a 500-page reference manual? Probably not. Okay, I'm going to have to accelerate is what that's telling me. So I got a couple of different approaches. The Roy Rogers approach. Mosey on over and fix it yourself. Take out what you want that section to read, copy out just like that. I showed the inline statement, copy that out into a text editor and make the corrections you need to make and say, this is how you do an inline. Just an inline. This is how you do a procedural call, just a procedural. This is how you do a BDOS call, just that, right? Define those individual elements you need the AI to do. I would have spent a lot less time doing that than trying to get it to fix the errors it found. Well, it didn't even know they were errors, trying to get it to fix its conception of what the actual reference manual said. Another approach, well, that's what I just said, copy out little bits here and there to the a la carte approach, just what you need, which is what I think would have been the faster method. You can try a second opinion approach. In other words, you try to use a different OCR. You may have better luck. Yeah. Yeah, and I tried that with Grok too. Mixed success. Mixed success. It's still created OCR errors, and when you're dealing with a large document like a 500-page document, it's tough finding all those errors where they occur. Yeah, it might take a long time. All right. So those are the basic things. The industry consensus is for OCR that probably AbiFine Reader is the best, but for a private user, you're going to be paying a subscription fee of $100 a year. If you're a corporation, I think that's something like $300 a year. If you do a lot of OCR, maybe it's worth it. I don't know. You can decide how much it's worth it to you when doing your hobby stuff. I don't know. All right. So this is what worked. After all of that mess, I basically said, okay, let's forget all trying to teach it all this stuff and forget the reference manual. I started a new session. I said, here's two programs. Here's my PAKU program. Here's my Ghost program. Please review it for undeclared variables. Please review it for forward references. Please review it for incorrect loop operation. And it uncertain enough about Pascal to really give me some insights on that. It gave me, okay, you're all clear on this. You're good on this. You're good on that. Oh, by the way, I found you didn't initialize this variable over here. Okay, great. Saved me a lot of debugging time. And then that's what I did with the second step, helping debug. I still have a problem. It's running, but it's got a bug. And I can't quite nail down what section of code is causing a bug. Ask for help. You can say, here's the program. And when the program does this, it fails at this, and I can't identify where the failure is in the code. And don't come back with suggestions. That'll be when my code is 3,000 or 4,000 lines on an ancient machine where I have to page down to get to the code. Having that suggestion of, oh, by the way, go to line 1753. Here you have this if statement that's never going to be called. Oh, okay, because I forgot that additional clause before it. Okay, great. I'll go back and fix that, and it helped me debug much faster. So in general on all this for the PAKU stuff, I said, start with an overall structure. Start with the goal of having it speed up individual tasks within implementing that structure, that architecture. And when the AI changes code in unexpected ways, ask it why. It's okay to say, hey, look, you changed that. Why did you change that? And sometimes I've had Grok come back to me and say, oh, I'm sorry. You're right. I shouldn't have changed that. Now, unfortunately, that's usually due to bit rot. And unfortunately, like I said, those hard errors persist and it may come back in a cycle or two. So just if you start seeing behavior like that, maybe it's best to start a new project, a new discussion, but bringing in some of the pieces from the old one to get it rolling again. Up to you. And also, don't be afraid to challenge AI. It's like a couple times it made suggestions, like when it wanted to change my program to a 320 by 200 graphics mode. I went, no, you're wrong. That's not the mode I asked for. I haven't asked for that mode. This is 160 I even pointed it to a website. This is how this mode is built. And it came back and went again, oh, you're right. Okay, great. Glad we got moved on. All right. Before I move on to the FPGA stuff, any questions about that whole PAKU program development? Yeah.
Was there anything novel that Rock came up with that you wouldn't have thought of yourself?
Um, Not in the writing of the code, but it came up with sort of a review of the performance of the code I didn't expect. And I thought that was novel because what happened was, I mean, you saw that flow chart I had with the process communications. I originally had the queue management at going out to the ghost at the top. So what was happening is that was starting the ghost processing on data that hadn't been fully filled in yet, right? And I hadn't caught it. And it comes back and says, by the way, your queue management, when you do it here, is going to result in incomplete data going out. And I said, okay, yeah, you're right. I went and fixed it. And it was a good thing for it to do. Now, let me move on to something a little different. I'm going to speed it up here. One of the things I'm working on for the S100 Computers Group is a replacement FPGA board for boards that you can no longer get on the S100 bus. The PC video board that's in my CompuPro chassis is very rare. It maybe comes up on eBay once every 1 or 2 years. When it does, it's going for $600 to $1,000. Okay, thank you. So I've created a board called the Chameleon where you can program an FPGA to replicate boards that you can't get anymore. Well, I'm working with Wayne Worthen, ROM WBW fame. If you've seen him on the RBC boards and so on, we have already one of his projects on one of our S100 computers boards. Well, we're trying to put it onto the Chameleon. Now, it's a big task because I've been a silicon designer before. I'm familiar with high-speed silicon backbone buses. And I wanted this thing to have an AXI interconnect bus. AXI is a multi-issue, multi-transaction bus defined by ARM. It's free. They open licensed on it so everybody can use it. That allows you any transaction to proceed across to any target or slave without affecting the transactions in place for the other modules in the system. So it basically increases the throughput of an architecture based on it. Well, so we're putting a Z80 on this. We're putting some HDMI displays. We're putting S100 bus interfaces on it. And I wanted all that to work across this AXI interconnect. And I'm starting to build it out slowly. And I've done AXI interconnects before. I built a memory controller on our T35 module. One of the tasks is these buses are 32 bits wide and the signals controlling them get huge. So it's a lot of typing, a huge amount of typing. So I asked AI, hey, can you design an AXI interface adapter in Verilog for the T80 module, which is a known Verilog module, and the master AXI interface ID for this component, and I gave him some examples. I gave him the T80 code, I gave him the defines, I gave him the top level, I gave him all the signals, and I asked him to do it. And he created a nice framework. Well, I looked at it and it was missing byte lane management. So I added, can you add byte lane management? Sure, no problem. Can you add user transaction states? Because I need to encode processor states. And I defined how I wanted him to do these user transaction states. Sure, no problem. And then I asked him, okay, great, those are fine, but you didn't use the width parameters that were in the define file. Can you please you match those to the AXI defines? Did all of that. Generated this. Took me all of about 10 minutes. I've never written an AXI interface in 10 minutes. So that's going to speed up the project. And it's going to be a big help on the Verilog stuff. Why did it work so fast? Well, all the documentation on these FPGA devices is all, it's new. It's not OCR'd to death. It's not bit rotted. And so there was a lot more comprehensive information that was true and correct. So it worked on it really well. All right. So here we are. This is the last slide. What are the conclusions? What do you all think? Are you going to try your own AI-assisted projects for doing and suggestions? And thank you. And feel free to throw a tomato at me if you think I got any of this wrong. So I forgot who's first. I thought you might have been.
Yeah.
Okay.
I, with the Cypress Pisa,
Okay.
has a version area and Verilog it uses. So what I typically use the AI for is to comments, because I'm on the spectrum and I kind of have some language processing issues. It's kind of like a 286 without a 287 processor.
Okay.
Processing. So I tend to use the AI to generate comments for all my always blocks.
Okay.
And I kind of use it a little bit to check the code. I'm still skeptical how AI treats Verilog.
Okay.
So,
Are you using it to comment the sensitivity list, or what are you doing for the always block?
above each always block, you're supposed to write comments telling you what it does.
Yeah. Okay. So just comment for the whole block. Okay.
Yeah.
Right. Okay. Yeah, that's interesting. Did you have a question related to that, or?
Yeah. So, what? So you think that's the best practice on using AI to write Verilog, or do you think I should actually try and have it write the whole program?
I think you need to do it modularly, right? Like I started with the defined architecture for the Chameleon 816, and that's why I started with just the T80 portion of it for an AXI interface. I think the modular approach is best because it containerizes the results, right? And you can more easily see, did it get it wrong?
Yeah, that's why I'm skeptical of the AI writing code. If it does get it wrong, sometimes you might not necessarily know. But thank you.
Okay. Sorry, I was gotten distracted. Somebody else had a question or comment? That was my thing there that I had. What do you think if people are going to lose their jobs over AI? Yeah. Well, okay. I was a little hesitant to even do this thing here, but I wanted to just like, you know what? We're not going to be fired from the vintage community for doing vintage work. If we are, then I think things have gotten a little weird. I don't think that's going to happen. This is a community of people who just want to work to the same goals, want to preserve this equipment, want to do more things with it, and it's not my work job. I'm not making money at it, so I don't really have any financial interest in it. I think it's troublesome because people hear about AI jobs for AI being lost, and how do you feel about it? What do you do with it? Are you enabling the system, right? I don't think giving ChatGPT or any of these AIs knowledge on how to program a 40-year-old Pascal compilation system is going to cause anybody's job to be lost, right? That seems a little bit on the absurd side to me. What do you think about that? If you're in a community group that really is anti-AI, and it's a sore subject, it's to me that's kind of like when you touch on politics in any kind of hobbyist group. Do you really need to go there? Well, and I explain my reasons, right? My day job uses two very powerful AIs, and I don't want bleeding between them to my private life. I want to keep my private life set from that. Yeah. Well, like I said, it's someone's personal decision. In my case, it was by factors that were engaged in my work job that I didn't want bleeding into my private job, and that was the next best AI to choose for the purpose. That's all. Yeah, I agree. I don't want to make it political. Unfortunately, it will be for a while because the whole subject of AI data centers and the raising of electricity costs, that's a big thing. You got to decide if that's something you want to deal with. But I can tell you, if you're asking it to do a Pascal program, you're not the power user, right? Yeah. Well, I would still recommend getting a good book on Verilog before you start asking the AI to do it. because there's several methods that go beyond what the AI will do, like clock fabric that you really should have down first. Okay, I think we're out of time. If anybody has any more questions, feel free to corner me outside. Thank you.